All right, so now we're going to look at the last thing a velocity versus time graph can tell me. We know that it can tell me the slope is the acceleration. It can tell me what the velocity is at any given time. And so the last thing it can tell me about is the displacement. So let's take the example where something is going at 3 meters per second, and it does that for 2 seconds. So if I just told you something was moving 3 meters per second, and it did that for 2 seconds, how far did it go? 6 meters. Okay. Now, I want you to envision this box. This box has one side that is 3 meters per second by one side that is 2 seconds. And if I try to find the area of that box, multiplying 3 meters per second times 2 seconds, I end up with 6 meters. So what that tells me is that the displacement is equal to what we call the area under the curve. Now, some of you might be thinking, area, Mr. Foster, but 6 meters isn't an area. Well, it's an area on a graph that has time, okay? And time and velocity. So it's okay that respect. Now, the other thing you might be thinking is displacement's a vector. That means it has two parts: magnitude, how big is the area, and direction. So now I'm going to tell you that there's such a thing as a negative area. Just after you wrapped your head around the whole idea that 6 meters was an area, how do I get a negative area? Well, how do I get a negative displacement? I have to be traveling in the negative direction, so I need a negative velocity. So whenever the area is below the curve, you're going to get a negative displacement. Whenever the area is above the curve, you're going to be getting a positive displacement. Now, if I have an equal area above and below the curve in a situation, those two areas, one positive, one negative, they cancel each other out. Okay. So let's look what happens when maybe I change my velocity. And so we're going to find two things here. The first thing we're going to find is the acceleration. So we know that the acceleration is equal to the slope. So the final is 5, the initial is 1. So A average, or the slope, is going to be 5 minus 1 divided by the time of 2, 0. So I get 5 minus 1 is 4. 4 divided by 2 is 2 meters per second squared is my slope. So for every second it goes up 2 meters per second. Okay, the next thing I want to do is find the area. Okay, now some of you might be going, ooh, well, what shape is that? That there is a trapezoid. So you might even be sharp enough to remember the area of a trapezoid equation, which would be the average of the bases times the height. So in other words, what we're doing is we're finding the average velocity and multiplying it by the time. How fast did you go and for how long on average? Now that works okay here, because really what that equation is doing is it's saying, well, what's the average between 1 and 5? Well, it's 3. And it's saying, okay, let's find the area of this rectangle, which is basically taking this little chunk here and flipping it over here to make that rectangle whole. And so what I end up with is, when I do the average of the bases, so 5 plus 1 divided by 2, all times my displacement, or my time, is 2 seconds, will give me my displacement, and so I'm left with 6 meters. So yes, you get 6 meters in there. Now for our last example, so now it's not a straight line, now it's curved. And so if I try to use the idea that average velocity times time gives me displacement, and I try 3 seconds again, what I find out is this triangle the same size as, or this shape over here, the same size as that shape over there. No, because this is not a trapezoid. And so in order to find this area under the curve, we're going to have to employ some different strategies. Now, in dual enrollment, we're not going to touch that. But in AP, we will go ahead and figure that out. And so I just want to give both of you kind of an idea of how I might be able to find that area under that curve. And I want you to start thinking about it because both of you will need to kind of have an idea and maybe how would I solve that. And so the kind of the premise to start out with is you say, well, let's just get an estimate of it. Because I don't have any curved lines like that in my geometry history. But if I made a bunch of boxes as such, and I took the area of each of those boxes and I added them up, I'd get a pretty rough estimate of what that area is. Now, if I want a better estimate of that area, what I'm going to want to do is I'm going to want to make the boxes a little skinnier. Okay, so now I've made those boxes skinnier, my estimate gets better. And so the idea that calculus is going to teach you eventually is that as you make those boxes closer to infinitely skinny, your answer gets closer to the correct answer. And so we're going to figure out how we can solve that in AP. Dual enrollment, that's just a mental thought process for you. There you go.